All right, so we're going to continue talking about section 6.1 now. So we went over the order of operation in the earlier video. So now we're going to talk about the distributive property. So we're about halfway down page 2. So the distributive property says, instead of doing this with order of operation, which is perfectly fine to do that, you could say 4 plus 5 is 9, then 9 times 3, we know that to be 27. So you can still get the same answer with order of operation if there's numbers to assess. But it is the same answer as distributing the multiplication. Again, it's called distributing or sharing the multiplication. This 3 is times this parenthesis, meaning that it's times each item in the parenthesis. So we can distribute it out and say it's 3 times the 4, and then it's also 3 times the 5. And that gives us the same result. That will be 12 and 15, which is also 27. But we use this property, the distributive property, to do algebra problems a lot too. So sometimes we can't use order of operation because you can see it looks like this. You know, we've got 3 times parenthesis x plus 4, and I can't assess that without knowing what x is if we're just doing some pure algebra problems. So we use the distributive property to expand that to 3 times x. We don't know what x is now, so we just leave it as a variable. And then 3 times 4, which is 12. So using the distributive property. Another example, 5 times x minus 7. So 5 times the x, we just put those together basically. We're saying 5 is multiplied by x. We don't usually show the little dot. We certainly don't want to put an x there. It would be confusing. So it's 5 times x, just 5x. And then 5 times a negative, you can go ahead and consider the subtract sign a negative sign on the 7, and consider this 5 and negative 7 is negative 35, different signs. Okay, let's distribute a negative sign. So negative 4 times x is negative 4x. Then negative times negative, considering these both negative signs, makes it a positive 20. All right, so I'd have you pause the video and do the 17 through 20, practice the distributive property. So you check your work on these. Number 20, 3 times 2x minus 5. Let me mention that. It's a little bit different since it has a coefficient here. You do the 3 times the 2x. Go ahead and multiply the 3 times the 2 part, get 6, and put the x on it. So it'll be 6x, and then 3 times minus 5. 6x minus 15 there. All right, so practice with distributive. We're working our way up to solving equations at the end of this section. So it's kind of a longer section because it practices the building blocks of solving equations in the first half of the section. So the next building block is combining like terms. So let's talk about like terms on the next page. So in algebra, they'll say like you can't add apples and oranges, if you've ever heard that, like an A and an O, apples and oranges do not combine. You can multiply them, but you cannot add or subtract unless you have exactly the same thing. You can add apples and apples, like if you have 2 apples and 3 apples, you can say you have 5 apples. That's how it is with like terms, with algebra. You have to have exactly the same variable, the same thing, like apples that you're adding together. So this x, like in this example, 3x plus 5x, say these are your apples or these are your oranges, but you got the same thing here. They're both in terms of x's, so we're allowed then to add their coefficients. 3x's plus 5x's is 8x's, combining like terms. So notice that 3x plus 5y does not simplify. You cannot combine. That's the apples and oranges I did. You cannot add different things here. You can multiply them, so I note that. You could say 3x times, or dot, would be better, 5y. You can multiply things that aren't the same variable. So you multiply apples and oranges. That would be 15, and then you'd say x times y. So that is doable, and we do some of that. But combining like terms, if you're adding and subtracting, they have to be exactly the same. So For solving equations, we will mostly be adding or combining like terms. Like terms must have the exact same variable raised to the exact same exponent. Only the numerical coefficients can be different. The numbers get combined in the like variable term left alone, such as we have 5x squared y plus 3x squared y. Notice this one has a little more going on, the x squared and the y, but they're exactly the same. We can combine and say 5 and 3 is 8, and then we leave this as is, x squared y. So when we're adding and subtracting, it has to be an exact match, and then we add or subtract the coefficients, leave that alone. All right, so you can pause the video, as always, and practice these like term combining. So on 21, I would combine the things that are alike. Negative 4x, I would get negative 7 plus 3, and then I would bring down the minus 8, and that would be simplified. 22. Combine the things you can. 7x and minus 4x is 3x. And sometimes it helps to circle them visually. You can see them better. These are the like terms here for the y's. 3y, and they're both positive. Look in front of them for the sign. So these are both positive. So 11y. Okay, next, 23. You can combine the minus 9x and the minus 2x, which is negative 11x, and bring down the 15. And by the way, those could be in the other order, like 15 minus 11x would be exactly fine as well. Okay, 24. P's and Q's and minus 15. So again, this might help you if visually you're having trouble kind of locating those, and then maybe underline the Q's or something to help you see which two go together. So combine the like parts. 2p and minus 3p makes minus 1p. And then for the Q's, they cancel out. Minus 4q and positive 4q are opposites. That's 0 Q's, and then minus 15. So in this one, you don't have to show. We could have just said minus p minus 15. Last one, 25. I'm going to do a little distributing on this. Now, if you're wondering, there's no equation on these yet. We're working our way up to the equation. That's the next thing. Probably make the next video, or maybe I'll do half and half. But if we were doing an equation, we would have an equal sign and then another side of that, and we'd be doing a little extra stuff. But here we're just practicing combining the like terms, assuming they're on the same side of the equation, using our add and subtract rules. So here I need to distribute first, what we practiced earlier. Distribute your 5 to the t and your positive, and notice it's positive 5 to the negative 2. Bring down your 7, and then combine any like terms. So 3t, 5t, like terms is 8t. And then I've got a 9, a minus 10, and a plus 7. So 9 minus 10 is minus 1. Then minus 1 plus 7, that's 6. And that's how it would simplify. All right, I think we'll go ahead and start talking about the solving the equations on this video. I'm sure I won't get through it, and we'll need to have another section. But let's go ahead and look at the next page, solving equations. And note, this is just a building block. We don't do this as much. We usually have an equation to solve and try to figure out what t is, what the variable solves to be by this equation solving method. But this helps us to clean up each side of the equation should it have a lot going on. You know, sometimes we can have an equation like, look at number 30 on the next page. 3k minus 12 plus k plus 2, you know, it's just a mess of terms. So we first of all, what I would consider clean it up before we try to solve an equation like this, we would do what we were just practicing. We would take each side of the equation. Notice there's always a left and a right side, the two sides, then that equal sign between them. So we clean up each side using what we just practiced, combine your like terms. So we got 3k and a positive k, which makes 4k. Then we've got a minus 12 and a positive 2. Again, we're using our addition subtraction rules. So we clean that up, simplify it by combining the like terms. Do the same thing to this other side in either order. If you want the k's first, 3k is the only k, and then I've got 5 and 2, 7. And then we're going to do what the new thing is, solve the equation. We have some steps for solving equations, but the first step is you want to clean it up first. Step 1 is clear any fractions and decimals. That's even a further step if you have fractions in it, which we haven't done that yet. We want to try to clear the fractions out of it as a first step. Second step is use your distributive property if anything needs distributed, kind of cleaning up like we were talking about here, and then combine any like terms on the left side and on the right side. So I would call step 1, 2, and 3 sort of clean it up first. Get your left side and your right side as simplified as you can by combining like terms, taking care of fractions and things, and then we hit what's really kind of the solving step. Step 4, which is we move the variables to one side and the numbers to the other side. So we can get our variables consolidated. Sometimes they're variables on both sides, not always, but if there are variables on both sides of the equation, you need to get those consolidated. To bring this 3K over to the left side, the way we get rid of it from the right side is we do the opposite. 3K and minus 3K would then be 0K, gone. But what you do to one side, you have to balance and do the other side. So I also minus 3K on this side. And then that gives me the consolidated K terms I can combine and say 1K or just K. I've still got a minus 10 and a 7. Then I want to get this 10 over to the other side. So it's a minus 10, so I'll do the opposite and plus 10. What I do to the one side, I have to do to the other. That leaves 1K, or let's just say K equals 7 and 10, 17. And then we've solved our first equation on this set. To know for sure if I did that right or not, I should check back in the original problem. If it truly is the answer, then 3 times 17 minus 12 plus 17 plus 2 should equal 5 plus 3 times 17 plus 2. You plug it back in for all of the variables and see if it works. So 3 times 17 is 51. Let's see, order of operations on each side. Okay, that's going to be 51 minus 12. What is that, 39? Plus 17 is 56, plus 2, 58. I hope. I'm trying to add and subtract in my head. That's never good. And then on the other side, I think I made it. 51 and 5 makes 56. And then plus 2. So the other side is also 58. And that's what we're looking for. What value for the variable makes the two sides equivalent, solves it, and keeps it equal, works. And that's the only one and only answer when you're solving these. You're looking for one answer. All right, so 17 it is. Okay, so again, you can pause the video and work on these and then come back in. That's what I always encourage you to do, but I'm going to work on with these to get answers for you to check your work. All right, so number 26, 3x minus 5 equals 28. Most of your equations won't have all of that gibberish that we just had. We won't have to do as much cleaning up on each side, just for emphasis to show what could happen. Most of the time it's a little cleaner like this. I don't see a fraction. I can't combine on the left side. There's only one thing on the right side. So it's usually cleaner than this last one we did. So I'm ready to jump to step 4 and get my variables to one side and numbers to the other. So I only have one variable term, 3x, so I'm going to let it set still, and that means this minus 5, I would like to move it across. To move something across the equal sign, we do the opposite sign, so minus 5 and plus 5 to cancel out, and then do the same thing on each side to keep it balanced. Now, you might have learned, if you might remember that the shortcut to this is just say whatever the sign a term is on one side, when it crosses over the equal sign, it's going to change it to its opposite. So if a minus 5 on the left, it becomes a plus 5 on the right. So anytime a term switches sides, it's opposite. And you're welcome to use that shortcut. This is more the theory of it and why it works. Then the last step on this one, this is a 3 times an x. I don't want the whole 3x to go away. I only want the 3 to go away. I want to know what x is, 1x. So I divide out just the 3 part. 3 divided by 3 makes a 1x or x. What I do to one side, I do to the other side. So 33 divided by 3 for an answer of 11. And then I should plug that back in, check it, make sure it makes 3 times 11, 33 minus 5. That should be 28, and it is. Checks out.